Hello, Honors Algebra students. Mr. Lawrence here, and excuse me, we are going to be solving systems today. And you're like, wait, we did that back in chapter 6. Yeah, we solved systems of linear equations. In this situation, we're going to have systems of a linear equation with a quadratic equation. We're going to solve them, that system. Okay, it doesn't have to be 2 linear or 3 linear equations. We're going to be mixing it up here. Now we're going to use the same 3 methods. We're going to solve by graphing, we're going to solve by elimination, and we're going to solve by substitution. So let's get right down to it. Let's solve this first one. Tell you what, it's so easy to graph the linear equation. I'm going to just do it first. My y-intercept is 2. My slope is -1. Now, I'm not actually going to draw my line yet, and you'll see why in a minute. I'll make sure to draw the line, because if I'm asked to solve by graphing, I better darn well have a continuous graph, not a discrete graph, right? Remember the difference between continuous and discrete? Okay, but there's the linear one. It took almost no effort, and so I did it. Okay, for this quadratic, well, let's see here. First of all, I need A, B, C. Easy as 1, -1, -2. And let's go find the vertices. I'm sorry, not the vertices. Let's go find the number of solutions. So I will do b squared minus 4ac, which I believe 1 plus 8, which will be 9. So there's going to be 2 solutions, right? So let's figure out what those 2 solutions are. Now, I'm going to use the quadratic formula to figure them out. So I'm going to go x equals the negative of b plus or minus the square root of the discriminant all over 2a. So that simplified is 1 plus or minus 3 over 2. Well, 1 plus 3 divided by 2 is 2. Look at that, I just found one of the solutions. Yeah, one of the zeros, or the roots, is 2, 0, and the linear equation goes through 2, 0. Okay, the other one is going to be 1 minus 3. 1 minus 3 is going to be -2. Divided by 2 is going to be -1. All right, there we go. Let's go find a vertex. Got to find it. Let me see the equation. Okay, so to find the x-coordinate of the vertex, I'm going to do x equals -b over 2a. So x is 1/2. Hey, let's check and make sure that makes sense. If the vertex, or the axis of symmetry, right, that's the equation of the axis of symmetry, should be smack dab in the middle of these 2 coordinates, right? Well, it's -1 plus 2. +1, cut in half, 1/2, yeah. So my x-coordinate is 1/2. So now I'm going to go find the y-coordinate. So I got squared minus x minus 2. It's going to be y equals 1/2 squared minus 1/2. And was it -2? I think it was, but I'll just double check. Yeah, it was -2. All right, so y is going to equal 1/4 minus 1/2 minus 2. So these two, one is double the other. So these two are going to make a -1/4 minus 2, so it's going to be -2 1/4. So right now, if I had an input-output table going, I would have, let's see, 1/2, -2 1/4. I would have 2, 0, and -1, 0. And you can tell there, this is 1.5 away, and that's 1.5 away. Okay, now I don't have both solutions though. Let me graph that point. 1/2, -2 1/4, it's going to be right around there. Okay, so I'm going to use some logic here. I wonder what would happen if, in my input-output table, I entered -2 in. I'm wondering, would I get this point out? I'm thinking I might. Okay, I'm not positive. If -2 doesn't work, I'll try -3. Right, but I'm going to go with -2 first. So I'm going to put -2 in. So I'm going to have y equals -2 squared minus -2 minus 2, right? Did I get the equation right? Let me make sure. X squared minus x minus 2. Yeah. Okay, so that's all good. Minus, yeah, all right. So this is going to be 4, right? And this is going to be 4 minus 2. And that's going to be 6. So that's not hitting where I thought it was going to hit. That's puzzling me a little bit. Something's telling me I have a silly mistake somewhere. I don't see it. Maybe you do. Hold on one second. I'm going to pause the video. Okay, I see my silly mistake. Yeah, it's right here. You guys probably saw it right away. I knew I was doing something wrong. That wouldn't be a positive 4. It's going to only be a positive 2. So these are going to cancel out and leave me with 4. And look at this. If I go plot the point -2, 4, look at that. I'm hitting the graph. So I'm hitting the graph there, and I'm also hitting it here. Now, by the way, just for the sake of symmetry, I could go to 3, and it's also going to be at 4. Okay, so now I better draw my graph here. Okay, just to show it, I do have the two solutions. So here's the linear equation. Comes like this, and I'm going to make it green. It's not easy being green. Having to spend each day the color of the leaves, when I think it would be nicer to be red or orange. Okay, anyway, enough with Kermit. And then my parabola, which you will laugh at, but don't laugh at me, it makes me cry, is going to do something like this. Again, it's not so easy with that. Okay, and so my two solutions for this are the point, well, x equals -2, and then x equals 2, right? Those are solutions. If I put x in those equations, I'll get the same y values out. All right, very good. Of course, I need the y coordinate is going to be 4, and the y coordinate for this one is going to be 0. Okay, so let's talk about solving by elimination. I don't know if you noticed this, but I kind of lined up my like terms, and I want these y's to cancel out because with quadratics, oftentimes I like them to equal 0. So I'm going to distribute a -1 to both sides of the green equation, the linear equation. And that way when I combine them, I'm going to get 0y's, or 0, minus x squared plus 60. Oh no, silly me. There is a plus 60 in there, but I totally skipped over our term. So it's plus 60, and then what am I going to get there? Plus 11x. Okay. I can check really quick and factor. It's pretty easy to factor this. So let me see here. If I need two factors of 60, let's subtract to get 11. I'm drawing a mental blank. I don't see it right off the top of my head. Oh, 15 and 4. Yeah, 15 and 4 are going to work, right? But that negative's bothering me. So I'll tell you what I'm going to do. When I'm feeling insecure, I'm going to go to the quadratic formula because I know it's going to work. So I'm going to go A, B, C. Easy as -1, 11, 60. Okay, and let's find the discriminant. It should come out to be a perfect square, so I'm going to do b squared minus 4ac. Well, it's definitely going to come out to be a positive, right? So it's going to be 121 plus 240, right? And if I add those together, what do I get? 361? Yeah, that's 19 squared, isn't it? Yes, it is. It's 19 squared. Okay, so x is going to equal -b plus or minus the square root of the discriminant all over 2a, which simplified is going to be -11 plus or minus 19 over -2. So x is going to equal -11 plus 19 is going to be 8 divided by 2 is going to be -4, and then -11 minus 19 is -30 divided by -2 is going to be +15. So when x are those values, the two equations will be intersecting each other. Now, you can you don't have to plug them into both equations. What we've got there, 28x plus 4. I'm going to take the green equation to get the y coordinates, okay? Y is going to equal 28x plus 4. And I'm going to, the y is going to equal 28 times 4, oh, negative 4, sorry, plus 4. And I'm also going to do y equals 28 times 15 plus 4. And I'm going to go ahead and let you do those on your own, but those will get you the two y coordinates. You could use the quadratic equation to get them, but it doesn't matter because you're going to end up with the same y coordinates. All right, last way is substitution, and we see that both equations are equal to y. So therefore, I can set the equations equal to each other. I'm going to go x squared minus 6x plus 10, and that's going to equal 4 minus x. Since it's a quadratic, I usually want it to equal 0. I'm going to subtract 4 from both sides, and I'm also going to add x to both sides. And when I do that, I'm going to end up with x squared minus 5x plus 6 equals 0. Oh my goodness, that is such an easy factor. I have to do it by factoring. It's too easy. Okay, so x is going to equal 2, or x is going to equal 3. And again, to figure out the y values, I'm just going to use that linear equation. I'll put 2 in there, and what y is going to equal 2. I put 3 in there, y is going to equal 1. You can check these on Desmos. Okay, it's pretty simple stuff. It's just taking something you already know and taking it a little bit deeper. That's it for the video, ladies and gentlemen. Mr. Lawrence signing off. Have a good night, everybody.